Hope you're keeping well. This video we're just going to sort of carry on the theme that we've been doing recently with the drive handles. We did one on for the Boxford, the Myford tool, and we showed you one for the Super 7. This one is basically a smaller version of what we did for the Boxford. Reason being, the downside with the handle I showed you last time is if you're doing any longer parts in the chuck, you can't get them into the spindle bore to hold them. So this one is basically a small version of the box one. It doesn't do the deck stop and it doesn't do the indexing. This is just a basic little drive handle. It's just a tapered sleeve that expands. So it's an expanding mandrel basically. Expands into the bore of the headstock and gives you the drive. So we'll show you that. Mainly made on the Boxford, and you'll see why we did it on the Boxford part way through. So there's our old frame back at the top from the Boxford, and this is a piece of bar stock that we're going to machine the Myford one out of. Not sure if it's the same one or not, but we'll see how we get on. So just taking this outside diameter down, because obviously the bar stock's a bit too long, so just faced it off, centre drilled it for a bit of support, and we'll just take this down to a sort of final outside diameter, if you will. And we'll also reduce the bar stock at the end for close to a bore diameter, so we can then put it in the chuck like we have here. That's the final diameter where the flats you'll see later will machine up on the spanner, and the drive handle will be attached to that end. We'll just put a chamfer on it as well. One, makes it look nice, and also there's no sharp edges. Got a bunch of these quick change tool posts from Sin Change Tools. So reverse that round in the chuck now. This is the diameter for the bore. I think it was 5/8 of an inch for the Myford Super 7, but if you're making it for your lathe, obviously measure it and check it and get it down to the right diameter that you need. Again, supported with the tailstock, so a longish piece. We're drilling this through now for the clearance. I'm using an M8 bolt, so this has just been drilled through. M8 for the clearance, so the draw barrel will go through, obviously. And that's drilled all the way through. This is now doing the taper, if you will, inside. So we just set the top slide of the compound slide to about 8 to 8.5 degrees, and you must leave this set, so when you machine the little plug bit, if you will, if that goes inside, it'll be exactly the same taper. And we machine this, so it's basically coming out a little bit at a time. You want the wall thickness where the tool is at the end of the bar, you want it about 1 millimetre, the wall thickness. Now this is a separate piece of material we've got. This is now going to make the plug, which will draw into the tape we just machined, which will obviously expand the mandrel inside the bore. So this is being drilled now, the M8 for the tapping size, which I think is 6.25mm. And we're just drilling down about 1 inch, that's all, because the plug will be probably about 5/8 to 3/4 at most. And now we're all friends back. This is why we machined this in the Boxford. So we can reattach this handle like I made in the previous videos. and there it is, providing the drive for the tapping. Now we've got the compound on the top side still set at that angle. We can now machine this plug, which will give us exactly the right angle. Just see the rubbing there. I've actually got the tools just set slightly wrong, and the back edge is just catching, causing the rubbing, the chattering noise. So the tool post just needs rotating around a bit to the right or clockwise, which I've done now. Carry machining this with no chatter whatsoever. You want this to be just not quite going in. You can see that it's just a tad sharp. It's perfect. So I'll just pull in nice. Be careful if you do this yourself with a file. Not really advised. We can knock it off with the chamfer tool, or just round the edge off. Just basically get rid of the sharp edges, and then just part it off. Nice, and slow it down. Plenty of cutting fluid. And bingo, there she is. And that's it. I'll just pull in. You can see the perfect taper and the wall thickness that we left when we machined the tape on the inside. I'm going to machine 2 flats now for the spanner. 180 degrees obviously for the second one. What we've actually done is worked out the overall diameter of the bar socket. Again, you choose. We're taking this down to 19mm flats, and also remember the thickness of the spanner, so we brought in from that edge. Give us the cut. So we've got two flats now. So we're just touching off. I've already worked out the difference, what needs to come off both sides. Obviously you work out the difference, divide it by 2, that gives you both sides. I think we're doing 1/2 mil cut at a time. I'm not using any cutting fluid, basically so you can see it more clearly, but please always use the cutting fluid. So another 1/2 mil. Lock your spindle, take your cut, and away you go. You can hear a little bit of vibration. Reason being, if you look at your rotary table, it's stuck out quite a long way with the chuck on the end, and then the part it's stuck out a long way. So that's why just 1/2 mil cuts and take it steady. That's final cut down to depth. So now we rotate 180. So loosen off the clamps on your rotary table. Yeah, and always remember, always use your minutes and seconds reading. The little points on the side gives you a rough idea, but always use those to get accurate. I just fed this with it, it's the same process, and we just go down to the same depth because we've already worked out what we need off each side. And test fit, and there you go, perfect fit. Now we reverse the part in the chuck, and now we're going to do the slots for the expanding part that goes inside the bore. As you can see, slowed it right down now. When you're using a slitting saw, slow them down. If you go too fast, you'll just burn your saw out. And as you can see, yes, plenty of cutting fluid on there. So that's one slot done. So this time, unlock your table, and we'll go around 90 degrees because we're doing obviously the 4 slots. Got a little bit better angle here for you hopefully, so you can see what's going on. So as you can see, the saw's running slow, and we're just feeding in nice and gentle. I've gone a bit slower than normal just so you can see it. Plenty cutting fluid. A little tip, you can see there, plenty of fluid. To the left off screen is where I'm stood, where you can't see the other half of the saw blade. If you squirt your fluid on there, because of the rotation of the blade, it actually brings the fluid into your cut. If you try and squirt it onto the part, the saw blade basically takes it off, so you're just getting no fluid on where you need it. So you spray it onto that outside edge, and you get a nice, it just takes it into the work for you. You get a nice amount of fluid where you need it. And now we've done this, each cut, we just go in the same depth, so we know each cut is got the same length. And then same thing again, just unlock, rotate 90 degrees, lock your tail back up, ready for your final slot. And again, we've just sped this up. Please never run your slitting saw at this sort of speed. You'll just burn it out. Just sped it up, just for the video. That's all 4 slots cut. I'm just going to drill these at the end. It's advisable for any slots to stop them cracking that are going to be moving, expanding, just to basically drill a little hole at the end. So I'm just going to centre all these and drill them through. Probably won't need them much on this because they won't move that much, but it's just better being safe than sorry. So there's our parts. I've just made a little handle. The actual nice chrome handle was off a job we're not being used for yet. I might make a new at the end. You can just see there the roll pin, which makes a drive pin. And that roll pin goes into the little hole. You can see the insert, the taper, the slots, the hole, and that just goes into that hole there, and that gives you the drive. So you're not just relying on the actual bolt, if you will. There's a little taper plug. It sits in the end. That's what will expand the mandrel. There's the handle with a crank in it, and the roll pin you can see It just fits in like that. This is an M8 bolt, works as a drawbar. And that just goes into the spindle bore. Your two spanners for the 19mm one we machined down that end. That allows you to lock this up. As you do this, obviously that draws a little plug up, expands the manual inside the bore. And obviously when you make a video you need the clearance for the casing where the Myford logo is there, so there's a little crank offset and then back again there, so it clears that. And there's your drive handle for the Myford Super 7. So there we go. Simple little drive handle for the Myford. This can be made as we made one for the Boxford for basically any lathe. Just want a simple drive handle. Obviously make your handle, and if you need the crank offset to avoid any casings, you know, make that to your spec. And also all the diameters, that's why I've not really gone through any diameters, just roughly told you what they were, but again, just make them to your lathe, what you need. And there you have it. So nice little drive handle, another one to go in the drawer for your little additions for your lathe. Hope you enjoyed it, YouTubers. If you don't mind liking and subscribing to the channel, it'd be fantastic. Until next time, it'll be right.